Now the thing with 4, this is the way I would do 4. If you take it the way they gave it to you, like this, and you just take a second and you put it in the other format. Because I don't like memorizing a couple different formats when they're really the same stupid thing. They really are the same thing. If I just subtract the z over, I get this. Right? So fx would be fx. Fy would be fy. And what's fz? -1, exactly. That's all. And they try to make it like, ooh, that's amazing, but it's the same stupid thing. If you solve for z, you're always going to have a 1 fz, but it's negative because you have to pull it back over. Right? Okay, maybe. All right. Number 5. What about number 5? Okay. I think B. Look back again at it. But that's a little evil because if you're not careful with how you look at it, they all look the same. The big thing there, that's kind of a silly thing. They pulled a 1 over somehow and didn't make it negative. So it's sort of like saying, what's a horizontal tangent line to the line y equals 7? Why is that a stupid question in a way? Because y equals 7 is a horizontal line. So what's the horizontal tangent line of y equals 7? Y equals 7. So what's the horizontal tangent, not the horizontal, but what am I trying to say? The tangent line. Not horizontal, I just gave that as an example. But what's the tangent line is something that's already linear, really. And if the tangent plane is something that's already linear, is the plane itself. It already is a plane. I don't have to make it into a plane. Right? So if I have this, then the tangent line is there at that point, right? But if I have a line, where's the tangent line? The line. So extend it. If I have a plane, where's the tangent plane? The plane. It's already a plane, right? It's like a simple case.
When it says it's a surface, that I was kind of thinking about something.
Oh yeah, they're being a little evil. When they say the surface x plus y plus z equals 1, that's like me saying the curve x equals 2. And that's not incorrect, but what's a little evil about me calling x equals to a curve? Because it's a stupid line, right? 2D. But it's still called a curve. It just happens to be a straight curve. But here it's a surface, and when I say surface, you guys should kind of think, right? But what is this? This is the surface is just a stupid plane already, right? So I don't have to do anything special. It's just itself. Itself is its own horizontal, not horizontal, but tangent plane. So 5 is definitely A. Good. Just repeat the equation. What about 6? Okay, I gotta vote for B. Vote for A. All right.
You gotta see.
So guys, who remembers how this is put together? The nice thing is it's a lot like that. Or actually, this is really just 1 because in 2D, Fy is always going to be 1. So it's like m times y minus its y, m times x minus its x. Now just extend that. This problem here is the linear approximation for this is going to be fx times x minus the x piece. So, right, the slope in the x direction times the x piece plus slope in the y direction times the y piece. Plus, now here's, it really is the slope of the z direction times the z piece, but the slope of the z direction is going to be 1. So it really is just f of AB. Or the output, whatever the z is, right? So now you just got to do that. Look at it like this. At the point AB, at the point, and actually let me be a little more specific here, at the point x naught, y naught. These kind of go to what? At the point x naught, y naught, both of these are, I don't care what fx and fy are, at the point x naught, y naught, these are
Zeros?
Help me out. Zeros, right? Because at the point x naught, y naught, what is the function value? F of x naught, y naught. Now what does it say? The minute I move a little bit in the x direction, and I move a little bit in the y direction, these pieces tell me about how much the z changes for each of those movements, right? So I'm at a certain point. I'm at here. Then I move a little bit in the x direction, a little bit in the y direction. And so these pieces kind of add to it or subtract if they're negative. The changes in z. Because what does f sub x really mean? What does f sub x really mean?
Y is kept constant.
Y is kept constant. And you let x vary, but it measures how much your output changes as you let x vary, right? So f of x is really, in a way, dz dx. You guys with me? In fact, I mean, that's basically, it's the partial of f with respect to x, and very often f is z. Z equals some function. How are we doing? So I like it when you're able to kind of, you can't quite read this in English the way you can when I teach statistics. If you've ever taken statistics, almost every equation you can read like a sentence. Here, you almost can. You start here and you go this far in this direction, this far in this direction, and you put them all together, it's going to tell you about where you end up. It's not perfect, of course, because these are based on that point. And the minute you move a little bit away from that point, these are not right anymore. You with me? We all know that, because just like on this picture, this points me in this, so if I move just a little bit, that's not going to be far off, but it's going to be off. Because the minute I move, it's gone down a little bit. It's an approximation, not an exact thing. Okay, so now all you got to do is throw all this together, and you should get, 6 is A. Cool. 6 is A. Okay, cool. What about 7? B? D, I like D. That's good. D. Stewart's page folds down. He's got D, E, Alright, so it should be B. And 7, you really do it the same, you do it the same way we just did this. You just create it for the function. And what function are we dealing with in number 7? It really just depends on how you want it. You can call it f of LWH if you really want to. And LW, or you can do f of XYZ, where x is the length and so forth. There's the volume of it. I'll find fx, fy, fz. The nice thing, what I just said is sort of true, but it's not necessary. The linear approximation for this is going to be fx, x minus x naught. And what's my x naught going to be? What's my y naught going to be? And why is this piece actually not really here? This is the piece I want to be careful about. This piece is kind of funny because how much does z change? It doesn't change at all. So this piece is not there. And in fact, in the book, they just give you this piece. But I'd like to show you the whole picture. That there it is, but it doesn't really show up because we assume something stays the same. And that's the one that we hold constant, right? So now I just got to look at the other ones, how much they change. So figure out what fx is, figure out what fy is. What's your x naught, y naught? It gives it to you. It started at 4 and 3, right? Now why don't you really need that though? Because x minus x naught is just how much the length changed. So that would be 0.2, right? Y minus y naught would be negative 0.2, I think it was. Yeah, cool. How we doing? All right, and then fx, what's fx? Sounds nice. YZ. Got it. What's fy?
XZ.
XZ. Cool. So then this will be YZ times 0.2 minus XZ. That's 0.2. Just putting the negative out there. And then just plug in those values and you're good. Right? Okay. Finish that out, and you should get negative 0.2.
So this,
These are going to be the points, these are going to be these. Because to be totally honest, you got to build this up around a certain given point, around the point, in this case, 4, 3, 1. So you build it up. Don't want to bring back a certain specter, but you always do it around a certain point. And then you put into here is going to be how much you actually moved by. So what are you going to put in for y? 3. And z, of course, is held at 1. So it'll be 3 times 1 times 0.2. X is 4. Z is held at 1. So you get 0.6 minus 0.8. There's your negative 0.2. So don't put in the new stuff for these points, because this linear approximation has to hold for that point. Then you plug in here how much you move by. Right?
that's the same thing as differentials, what they call it.
It's related to differentials. It just is, instead of a delta x, it's a dx. You see what I'm saying? So the difference between linear approximation and differentials is like, you can do it, Jeff, there.
Well, dx is also...
X minus x naught is really delta x, right? That delta means a gross big step. Whereas with differentials, I wouldn't put delta x, I would put dx.
And
Meaning,
that's the same value, right? Basically, that's the same value.
officially, I wouldn't use differentials here because 0.2 is a very large step, right, compared to what it could be. But for that kind of leads me up into number 8. Yeah, to do dz. Yeah, good. Partial x dx, partial y dy. I love it. So partial x would be 12x cubed ey dx plus partial ly is the same thing. dy. Done. That's very often what you call a total derivative. That's a differential. And I think number 9 is the same thing, just with the slightly uglier equation, but you can kind of eliminate one of those answers off the bat, because the one with the dz, I mean the partial with z, it's got to be negative, because the z is on the bottom. So which one is it? B, I love it. Because z to the negative 1 would become negative z to the negative 2. It's got to be the one that's got z squared on the bottom. There you go. Cool. And now here we go. Number 10 is the nuts and bolts problem on this thing.
Okay.
Alright, so I got A, I got B. Does anybody say C? C is the one you can kind of rule out pretty quickly. Because again, the Z is positive and it can't be. So 10. And of course, if we do this enough, you start to remember this. It's really the same as before, except now my differential operator is not just the straight up derivative, it's the gradient. So a lot of times we just replace what we used to do with just a straight derivative, we do it with a gradient now. And the process is the same. To find the tangent plane, I first, of course, need a normal vector, which is the gradient. So what's the gradient going to be of this? Cool. You could become an x, there you go. And then I want it at the point 1, 2, negative 1. So it'll be 2, 4, negative 2. So that is my normal vector. I love it. So those are my coefficients, and I throw them in there on top of x minus x naught business. Cool. So I'll put there 2, x minus 1, 4, y minus 2, minus 2, z plus 1. Cool. And I just solve that, divide by 2. You should end up with A. That is A. Okay, cool. So we'll do the other side here in a little bit. Because we still have some of the 12/8 to finish out. You guys want to take a break? Yes. All right, come back in 10 minutes. Oh, yeah.
Let's go. Hey, what the hell is this?
If you got on your point back, then you could.
Serious?
Pretty sure I was actually got all the quizzes changed. Did you
I
correct that?
lost it, not found yet.
Okay, so it doesn't say least, right? Did you get a 95 on the first time?
I got
99, okay. Did you get all your quiz point corrections right?
this one, I didn't get the correction, but I didn't get the oh, I can go back
So it's proportional, so I would, you didn't quite get all the quiz corrections right. So you should have gotten the points back.
I think we're gonna go.
You got half the points you could, so I think you have to get it on your quiz grade. So it's proportional to how many points you got. So the better job you do with corrections, the more up your quiz grade is. Or the test rate is higher.
I want some almonds.
Did you understand this number 2? Yeah, it's a level curve. When we say level curve, we mean something 3 dimensions, right?
You can't recorrect something. You already corrected it. Oh, you haven't corrected it all?
because I didn't give you the copy of the correct.
Wait, a level
I didn't grade it, I didn't do the correct.
Oh, I see, you can't find your original.
Because it's 0, a level surface, 0 means a surface.
Yo, what's up, dog?
What I normally do is.
Like I know, okay, 3 dimensions, the maximum we can go is.
So I just have to know which version you have.
Surfaces.
I had the version.
Surfaces with.
If you got a minute, you can go with me after class.
You know, you're gonna. That's what I was.
Excuse me, is that how you ask?
I guess I don't have to take this part, do I?
Yes.